Okay, today we're going to be talking about composition of transformation. What we're trying to accomplish out of this: identify and draw composition transformations such as a glide reflection. Okay, I'll come back to this slide if you need it. You only have about 8 minutes to copy it, so here we go. What are we talking about when we say composition of transformation? It's one transformation followed by another. Compositions of transformations. One transformation followed by another. We saw that yesterday, right? Rotation and then a reflection. A translation and then a rotation, right? A glide reflection is an example of a composition of a transformation. And it is when it's the composition of a translation and a reflection across a line parallel to the translation vector. Write those definitions down.
So is it every day going to be a new person?
Do what?
Is it every day going to be a new person?
Oh, probably just you or Lucas. Okay. Once you get that written down, who's got it written down? Emily. In a glide reflection, what are the two transformations that take place? Very good. A translation and then a reflection. Now see that? You just wrote it down, but now I want you to understand what it means. Those two transformations take place in the same move. Think of it like a play or a move. Or we had to use this in first block. You go to McDonald's, right? You could order a hamburger, French fries, or a drink. Or if you get a value meal, you can get a hamburger, French fries, and a drink in one, right? Composition of transformations is like getting a value meal. You can do all those things in one particular move. They're the ones who weren't complaining about our take-home quiz, so, but I'll just leave that. I'll just leave that there, as we say nowadays, right? 10 seconds. Okay. Guys, I want you to write down this example. Here's an example of this composition of transformation. Write it down, please. I want you to write the sentence and then draw the example. Go, Douglas. Okay, glide reflection that maps triangle JKL to triangle J prime K prime L prime is the composition of a translation along B followed by a reflection across line L. Right? So we're clear about something. It says that the translation occurs along B. That means in the same direction as line B. Right? B with an arrow pointing, correct? Is going in the same direction as that particular line. You got 10 seconds. 3, 2. We'll come back. All right. Composition of two isometries is an isometry. Oh, that's stunning, right? This is the important one, too. The image after each transformation is congruent to the previous image. All of this talks about what we call rigid motion, rigid transformations. Remember, we defined rigid transformations and we said everything is congruent throughout the transformation. The same size, the same shape. Okay, that is still true even if we have a composition of transformation. Even though I'm applying more than one transformation, I still have isometry. I still have congruency throughout. So no matter if I flip it, turn it, or slide it, or as some of us would say in fill in the blank, flips it, turns it, and slides it with a capital T. Don't do that. I'm going to. Okay, next. Oh, here we go. I'll draw this. Draw the result of the composition of isometries or isometries. Triangle KLM has vertices K, L, and M. Rotate KLM 180 degrees without the origin and then reflect it across the y-axis.
This is what I was thinking about.
Okay, here we go. Anytime I have a 180 degree rotation, all I have to do is take the opposite of my x and y coordinates. That's it. The first rotation, or the rotation I'm going to do, the first transformation. Negative x, negative y becomes negative 4, 1, negative 5, 2, then what? Okay, negative 1, 4. Let me plot those points. Okay, that's it. K goes from 4, negative 1 to negative 4, 1. L goes to negative 5, 2. And M goes negative 1, 4. That is a 180 degree rotation about the origin. Okay? First part of the problem, rotating at 180 degrees. Second part of the problem, reflected across the y-axis. Whenever I reflect across the y-axis, my y values don't change, and I take the opposite of my x values. So instead of -4, I'm at +4. Y stays the same. Instead of -5, I'm at +5. Y stays the same. Instead of -1, I'm at +1. And y stays the same. 4, 1, 5, 2, 1, 4. That is my composition of transformation with a new KLM. Okay? So A prime, I believe, L prime, M prime. I have a rotation and then a reflection. Okay?
Reflections are easier.
They are. Here's some proof. Okay? There's some proof.
Oh, you just copy it and-
Oh, okay. Yeah, we're going to talk about some of these principles involved with this, okay? My rotation and then a reflection is very similar to just a regular old reflection. Okay. So, rotate the image, reflect the image, track the image, and the image. I do want you to do this though. Draw this out, please. Take a few minutes. Write it out, draw it out. Take the time. Triangle JKL has vertices J, K, and L, on which you could first reflect across the x-axis and then rotate 180 degrees about the origin. Take the time and draw this out, please. You flip it across the X and then rotate it. Flip it across the X. The X coordinates stay the same. The Y coordinates go from negative to positive and positive to negative. And then you rotate it. Yes. Move it during the steps. Your first step is to reflect. Your second step is to rotate.
Yeah, what about zero?
Reflect. 1, -2 becomes 1. I'm sorry, 1, +2. 3, 0 stays at 3, 0. 4, -2 becomes 4, +2. Got me? There. Yeah. There's my first particular composition. Sorry, my first transformation. And I'm going to rotate it. Remember, anything that was, well, all of these would be positive, positive. So everything's going to get changed. Okay? So instead of 1, +2, I go to -1, -2. This is difficult. -1, -2. -3, 0. -4, -2. Now I've got
That almost
my
looks like a
final
reflection.
It does, and that's one of the principles that I hope you you see.
Is it real reflection? Because the water.
It can be. That's one of the things we're going to look at here in a second. Okay. All right, guys, check your work with mine. That's what you should have ended up with. Okay. This would be L prime, K prime, J prime. Or
What
double prime.
about the other one?
Yeah, they can be. It depends on what I'm doing. So in this situation, I would probably want your final answer to look like that. The biggest thing I want you to worry about is if your triangle is where it's supposed to be right now. Okay. Right. So when you do a live reflection, you don't use. This is a live reflection. You should not use a prime for your very first translation. That's a all right. Here we go. Here's what you need to write down. This first part. Composition of two reflections across two parallel lines is equivalent to a translation. Write that down. Composition of two reflections across two parallel lines is equivalent to a translation. Check it out. If I had reflected the blue triangle to the green triangle, and then reflected the green triangle to the red triangle, that would have been the same as just translating the blue triangle to the red triangle. Say it again. I had write down. Douglas, you got to start paying attention. That's going to be a quick semester. It's going to be actually going to be a long year. This is just supposed to be a semester class. Write this down. Composition of two reflections across two parallel lines is equivalent to a translation. Blue triangle gets reflected to the green triangle, and the green triangle gets reflected to the red triangle. That would be the same thing as if I just translated the blue triangle to the red triangle. Next, make sure you write down this. Composition of two reflections across two intersecting lines is equivalent to a rotation. And finally, when you get done with that, please write down any translation or rotation is equivalent to a composition of two reflections. Any translation or rotation is equivalent to a composition of two reflections. Make sure you have this sentence, and this sentence written down. I think on your fill in the blank, some of those bullet points are on there too, but we'll deal with those when we get there, right, Corey? Corey, you want to go back to grammar for a second? We're done with that? Okay. All right, guys. That's all I got. Okay, that is all I got for today.